CO2 in EOR. CO2 in enhanced oil recovery is a technique used to extract additional oil from an existing reservoir. CO2 is injected into the oil reservoir, where it mixes with the crude oil. This process reduces the oil's viscosity, making it easier to flow. CO2 is a resource. While large stationary facilities traditionally view CO2 as waste, it's actually useful in enhanced oil recovery, EOR, where it helps extract more hydrocarbons from existing wells. EOR, CCS. Partnerships. The future of the EOR industry might involve forming partnerships with power plants and other significant CO2 emitters. These alliances would focus on economically capturing and utilizing CO2 for EOR, while also storing it, a process known as carbon capture and storage, or CCS. Limited CCS industry. The integration of these activities could create a niche CCS industry driven by the demand from EOR. By turning CO2 into a valuable resource, these partnerships can promote economic and environmental benefits. This approach not only helps in reducing CO2 emissions but also maximizes the utility of existing hydrocarbon resources, offering a potential win-win scenario for both energy production and environmental management. The injected CO2 dissolves in the oil, causing it to expand and become less viscous, which aids in releasing the oil from the rock pores. By lowering the interfacial tension and improving oil mobility, more oil can be pushed towards the production wells, thereby increasing the recovery from a reservoir. After the oil is brought to the surface, CO2 is separated and re-injected in a closed-loop system to minimize waste and maximize efficiency. CO2 EOR not only helps in extracting more oil from the fields but also provides a way to sequester CO2, contributing to reducing greenhouse gas emissions. However, its implementation can be expensive and is contingent on factors like oil prices and reservoir conditions. Evaluation of the project includes screening, laboratory testing with sector modeling and full field modeling followed by project execution. Phase 1 is to screen the field against the geologic and reservoir characteristics of other CO2 EOR project. From these reviews, the project will meet the screening and economic criteria justifying further detail study. Phase 3 of the evaluation include a full field reservoir model, flood design, facility design, construction and implementation of the project. Various flooding schemes and wellbore utilities will be reviewed to optimize the oil production rates and recoveries. Carbon capture, utilization, and storage is a technology used to reduce carbon dioxide, CO2, emissions from industrial processes by capturing the CO2 before it enters the atmosphere, utilizing it in various applications, or storing it underground. Enhanced oil recovery, EOR, is one of the primary utilization methods for captured CO2. This process not only helps in extracting more oil from the reservoir but also stores the injected CO2 underground, providing a dual benefit of energy production and environmental mitigation by reducing the net amount of CO2 released into the atmosphere. The integration of CCS with EOR can be an economically attractive method as the revenue from the additional oil production can help offset the costs of capturing and processing CO2. This can make CCUS projects more financially viable while contributing to emissions reduction efforts.